Welcome to Ready Physics. An electric lamp of 100 ohms and a toaster of resistance 50 ohms and a water filter of resistance 500 ohms are connected in parallel to 220 volts source. Okay. What is the resistance of electric iron connected to the same source that takes as much as current? All the three appliances, and what is the current through it? First of all, when we can say the resistance are connected in parallel. So first we'll discuss about this parallel combination. For example, this is a resistor. Here I am having one resistor. Let me take this is an electric lamp of a 100 ohms resistor. And we are having another resistor, so which is that a toaster of 50 ohms resistor. And we are having water filter. So water filter we are having third resistor, which is a 500 ohms resistor. So three resistors we are having now. And they said they connected in parallel. Parallel means what? Parallel means if the terminals are connected to the same two nodes. So this resistor, these are called terminals. This resistor, these are called terminals. This resistor, these are called terminals. If all three terminals, these three terminals are connected to the same two nodes. So this is node 1. Point 1 and this is node 2. So all the resistors are connected to the same two nodes. Then we can say these resistors are connected in parallel. Very good. And after that, what they said, to a 220 volts, and this total combination is connected to 220 volts. This is it, 220 volts. 220 volts. This is what they said. So what is the, okay, first we will see about this part. After that we will discuss this part. Why? Because we need current for doing this. So what is the resistance of electric current, electric iron connected to the same source that takes as much current as all three appliances. So that takes as much current as all three appliances. That means how much current these three appliances will drag, that much of current only one resistor will drag. So here we are having another resistance which is connected to the same source, right? So here we are having another resistance here like this, another resistance here like this. So this resistance they are asking us to find, but they given the current. So what is this current means? How much current these three will take, that much of current we should give to this one. Okay. So now what we are going to do? So we are going to, first of all we are going to find out how much current these three resistance will take. First we will see that one. After that we will find this resistance. So first one we will see. So this is the 220 volts and first part here part. And we have three resistance, right? So this is the two nodes points here and 3. So this is resistance 1, resistance 2 and resistance 3, and these all comes to same point. So one is 100, another one is 50, another one is 500 ohms. And we know that the battery is given as 220 volts. So since the positive terminal is there, the current will goes on this direction. So what is the equivalent circuit of this one more? Because here the current will divides into three parts. In parallel combination, current will divides. So this is one part I1, I2, I3, like that it will divides. So if you want, we can find this one in two ways. One is finding this current, this current, this current, and adding all those currents. Or second way is making the equivalent resistance of this one and simply finding current by using Ohm's law. So I will prefer the second part more. Second part means I will simply write the equivalent resistance of this circuit. So how we can write the equivalent resistance means, so instead of three resistance I am going to use only one resistance. So this resistance we can call it as equivalent resistance or equivalent resistance. And here we are having current I. But how to find this R equivalent? R equivalent we can find by using formula. When the resistance are connected in parallel, then the resistance R equivalent is equal to 1 by R1 plus 1 by R2 plus 1 by R3. By using this formula we can find out R equivalent. So that is equal to 1 by R1, which is in case 100, 100, 50, 500. So 1 by 50 plus 1 by 500. Now what we need to do is doing LCM, that's all. So this is 500, so 5 times, and this is 10 times, and this is 1 time. This is 1 by R equivalent. Now what is R equivalent now? R equivalent is equal to simply inverse of it. So how much it will come? So 500 divided by 16. So 500 divided by 16 is the R equivalent. Okay, so we find now R equivalent also. We just found. Now what we need to do is we need to find current, because that is what we want to find in this circuit. So how to find current now? By applying Ohm's law. V is equal to IR. So V we know this one, and R equivalent we find, and I we need to find. So I am going to use the formula. So I is equal to I equivalent, we can say if you want, not a problem. I equivalent is equal to V by R equivalent. So what is V ma? What is V? 220 volts. Sorry, this is 220 volts. So 220 divided by 500 divided by 16. So the 16 will goes upside. So 220 into 16 divided by 500. Now if you do cancellations, you will get as 6.4 amperes. So I equivalent current is equal to 6.4 amperes. This is what we need. So what we found exactly? We found that how much current this 3 resistance will drag. Okay, that is what we found now. So that means for 220 volt source is there, R1, R2, R3 resistance are there. These three resistance combinedly, how much current they will drag from this source indicates that 6.4 amperes they will drag. Okay, that is what we found. Now we will comes to second. So what is the resistance of electric iron which is connected to the same source and that takes as much current as 3 appliances? And what is the current through it? 3 appliances, and what is the current through it? Okay. So what he is saying? He is saying that if I am going to connect another resistance, so which is in this case he is saying electric iron, I will connect here, and this will take how much current? Takes as much current as 3 appliances. These 3 appliances, how much current it will take? That much of current this one resistance only it will take. That means he is saying that this current which is going in this resistance is equal to how much? 6.4 amperes. This is what he is saying. How much current these 3 combinedly they are taking? That much of current this one resistor only it will take. That is what he is saying. Okay, and he is asking us to find resistance R. So that is what he is asking us. Okay, and in parallel conditions, in parallel connections, there is one good thing, because all resistance they will get same voltage. For example, here 220 volts is there. So in parallel, this will get 220 volts. This one also will get 220 volts. This one also will get 220 volts. This one also will get 220 volts. So this one also will get 220 volts. Now we are having current which is 6.4 amperes and we are having voltage which is 220 volts, and we need to find R in this branch. So how we can find? By using Ohm's law. That's all simple. So by using Ohm's law, what we can say now? By using Ohm's law, V is equal to IR. So we need to find R. So here I is doing multiplication. If it goes here, I is doing multiplication. If it goes this side, so it will do division. So V by I will come. So what is V? What is V? V is 220 volts. And what is I? 6.4 amperes. 6.4 amperes. And how much resistance will come now? To do the calculation, so 220 volts divided by 6.4 amperes, you will get 34.37 ohms. 34.37 ohms. So for the answer for it, so the resistance of electric iron electric iron is 34.37 ohms. 34.37 ohms. And how much current it is flowing? How much current it will drag more? How much current? So, and current flowing through it is 6.4 ampere. 6.4 ampere. Units are very important, so do not forget to write the units. Okay, that's all. So thank you.